So I was asked if I could make a build video for my Sawstop Contractor saw mobile base. So this is possibly the only video, but I may end up having to make several. So initially, we'll see if this actually comes out on the camera. Initially I tried to make that diagram. Needless to say, when I showed somebody, my friend who helps with a lot of projects, he said, "Are you crazy? I just look at that and my eyes bug out." So I took that and I scanned it in, and I made a slightly more, well, hopefully less complex diagram. And I wrote up, and I'm going to write these in the description as well, most likely, but this is the list of bolts and boards. And I broke the original diagram down into this first diagram, which has the sides and the levers, and then a second diagram that has the front and the rod and the actual piece that pulls the sides down. So and there's sections like, here's the front pipe area with dimensions. So if you use a 2x4, you would use the center dimensions. Yeah, but I would more if I had to do it again, I'd probably use a 2x6. I just didn't have a spare piece of 2x6. Where you would run a 2x6 lengthwise in this direction, and then you could screw it in to the 2x4 on the front there using deck screws to attach it. Drill the hole so it's 1 inch up, and in this case around the hole to prevent splitting. I used drilled and put 3-inch deck screws around the hole, so the 2x4, the screws come in from the side. For the 2x6, I would put the screws up from the bottom before you attach it. And I realize this is a little bit out of joint, but hopefully some of it will make sense. So I'm just covering the diagram first. So here, this would be the wheel placement on the 2x6s. So with the hinge, the wheel is 5/8 of an inch from the hinge side of the 2x6 and about 1.5 inches from the end of the 2x6. So to start, basically, I would recommend getting all the pieces cut ahead of time. When I did this, I built it as I went, so I didn't have everything cut at the same time, but I'll try and cover it as we go. So for this would be the sides, and for a given side, first you cut the 2x4 to length. Now what you need to decide is how far you want the 2x4s to come out. Do you want it to meet at the corner? Do you want to have a corner like this? What kind of joint do you have? Because depending on how you want that cut, you may, like for example, if you want the front to come the whole way across and end at this edge, you would cut this shorter or shove this board back and then make the front piece longer so it extends to there. So that's a decision that, that's an aesthetic decision, but also if you want to have, I don't currently, but if you want to have a piece that comes from the saw base over to the table extension base, and say you want to build this all in with a cabinet and have additional wheels or whatnot there, you'd have to decide how you want this to go. Me, I figure, alright, I'll get this to start. Eventually I want to build something on this right side, but for now, this is what I needed, so I started from there. So for the very first pieces, which the sideboards are 26 and 5/8 inch long, so what I did, and I think I can show it. Yes, I can kind of show it from here. So you see the hole right there. That's one of the holes where this is. So what I did was I figured out that I wanted the 2x4 basically to come down approximately the same length as the frame. So I did not want this 2x4 edge to stick out past the edge of the frame, because initially I hadn't figured out how I was going to do the front. So I cut it to length on my miter saw. Again, you don't need to use a miter saw for this. You could use a hand saw. Miter saw made it nice and square. And then I cut it to length, held it up against with the right height, because again, there's this flat section that you can kind of see there where the bolt... actually, we'll go back around this other side. Yeah, so you can see this flat section. It's the same geometry on all the sides. So if you go straight down from here, the straight down intersection is right at the bottom of this flat part. So take the 2x4, set it, and it stops right at the flat. Hold it there, and then go on the inside with a Sharpie or pencil or some other marker. Mark the hole on the 2x4. Hold it nice and still. Mark both holes. Take it out, drill it, and then you would be able to attach that board. Now again, if I had to do this over, what I would do is I would have the sides all cut and the 2x6 pieces inside all cut. Oh, one other piece of information that might be useful. I had 2x4s and 2x6s available. If you don't have that available, this is the size of the 2x4s, which is basically 1.5 by 3.5. They say 2x4, but we haven't had that for ages. It's 1.5 by 5.5 for 2x6, which ends up being around 37 millimeters by 88 millimeters, 37 by 137 millimeters, approximately. Again, to some extent, this depends on what size of wood you have. You could actually use 1.5 inch thick, but you could create that by having 2 pieces of 3/4 inch plywood that are fairly solid with no gaps, because you don't want it to crunch. So good pieces of plywood to get that thickness. Similar with the 2x6, I had pieces of 2x6. 2 pieces of plywood that were glued together would also work just fine. The important thing though is, well, for me at least, have something that size. So what I would recommend is, because everything is centered on the center line of the saw, this goes from here to the other side, move in slightly, and I centered the 2x6 between the legs and attached it. So if you use the diagram and you have all these cut to start, you can drill all the holes and get everything all set up and aligned similar to here, out away from the saw, get it all fit and make sure it all works, and then put it together. I would recommend putting these levers such that there is about, I realize it's hard to tell there, but that's like a 1/2 inch. So I would recommend having like a 1/2 inch gap. I would also recommend you notice that, I'm trying to go fairly square, that the rope is directly straight above the left hand side of the centerpiece, and I recommend that so there's not any sideways torque pulling. It's all straight down. It'll go a little bit better. Let's see what else. I would also recommend attaching the levers to the 2x6s prior to installing the hinges on the sideboards. The reason I say that is I did it step by step, and I had to take it back off. So I had the 2x4s on the sides, then I attached the hinges and the 2x6s, and then I figured out, okay, got to do all that, had the wheels on, then I figured out what length I wanted to do for the 2x4s for the levers. Then I had to take the 2x6 off because I couldn't screw down in to hold that. There are deck screws holding that. You could also use bolts to hold them together. I've done that on a previous project. It works just fine. Speaking of fasteners, and I realize this is jumping all over the place. I may have to do this again, but here's the pack of hinges that I got, that I took some of the hinges out. Here is the lag screw. You don't have to use lag screws to hold this on, the hinges on. You can actually use bolts. I had a lag screw break off and I had to replace it with a bolt. If I had to do it again, I'd probably use bolts. I had a whole bunch of lag screws, so I figured I might as well use those. But if you do use lag screws and you have to take them out, hand tighten the screw back into the threads that it makes into the wood. Then you don't strip out the wooden threads that it makes when it goes in, and that works a lot better. So this is the lag screw that I used, and this all looks to have moved. This was the 5/16 bolts that I was using. So the solid piece and then threads. This is the 3/8 by 16 thread. No, this is the 1/4 inch bolt. Sorry, it's hard when you're looking at a camera and you're looking at the screen, not where you're pointing. So this is the 1/4 inch bolt, and you can kind of see how long that is. So I'm trying to show it this way, just in case somebody is using metric, they know approximately the kind of screws and how long they are in metric. Or you could do the math and figure it out. So for the 3/16 bolts by 3.5 inches long, it has the solid and then the screw, the threads. So those are those. Let's see. The other important bit, so that covers the side pieces. Yeah, so center that, center this. For the attachment of this centerpiece, so what you need, oh, and the wheels, that's another piece. So depending on the size of wheels you have, I have a 2-inch steel wheel from Home Depot, just because that's what I had available and they're nice and strong. You could use other size wheels. If you use a different size wheels, the key with the wheels, anytime you have wheels, they rotate obviously around the center section. And can I get in there? Yes, kind of. So if this is rotated one direction, like say forward, if it's rotated in this direction, the 2x6 does not have to, or the 2x6 will set down lower in its arc than if it's pointing the opposite direction. If it's pointing the opposite direction, like I'm trying to shove there, and it's bumping into the floor. So what that means is, depending on your placement of the wheels, and I did try and get them as close to the corners as I could, depending on the placement of your wheels, all that's in size of the wheels, that's going to mean how steep of an angle you're going to have to allow the levers to come up before the saw rests completely on the ground. So depending on how far you have to go from the full tilted level or full tilted amount of the angle of the levers to flat, or as far down as you need to get the wheels all to engage, that's the distance, and you could measure that vertical distance. That's the distance you need around the circumference of however you build this center section to go. So what I would recommend is, and you're going to have to play around depending on what materials you have available. If I had to do this over again, I would probably come down with the rope, over, up around, across, up around, down, over, and up. Meaning loop it around carefully so it cannot pull out of the attachment point. Mine, I just have knots there that are not necessarily the most stable, but it won't pull down through. See if I can get clear in there. It won't pull down through this attachment point. So as long as the thread, the rope is held on tightly and won't pull down and release, you're good. If I had had a longer piece of rope versus two smaller pieces, I probably would have gone down, over, looped around, over, and back up. So it's one solid piece, but I did not have that available. But anyway, the distance you need to go in the vertical travel is the circumference of the circle you need to make with whatever pieces of wood or other attachments. You could have all sorts of things attached there such that would work. I used, again, the pieces of bolts that I described before. Those were the 1/4 inch by 2.5 inch bolts. As long as they don't scrape the floor, you can have all sorts of different attachments. You just need something that has the circumference of travel based on the amount of turn that you use has to be equivalent to the vertical distance that you need to pull down the levers. I would also recommend 2x6s, not 2x4s, for these pieces. And I don't know that I would use, I probably would work with plywood. I think I would still want to use a solid piece of wood for the levers. That might be a little stronger. Or you could do a laminated piece and it might be alright. Again, you just need something that will pull down successfully to raise up the wheels. A 2x6, the reason that would be better is right now you can see that this piece of wood, and it's hard to get in here, it moves around. A 2x6 would be wider and it'd be easier to have something to keep this from coming off, because right now this would work its way over to the side and then maybe fall. The other thing I would recommend for this side piece, you notice I only had just a tiny bit of metal on this pipe. I would recommend a 2-foot piece of pipe coming through here, and then this attachment would be much easier to do. You wouldn't have to worry so much about the exact placement. Again, these bolts, the 3.5 inch bolts, were more to keep it from moving side to side and this sliding off. I needed this extra attachment point here because otherwise the twisting was not working. The other thing with this 3.5 inch bolt, I had to actually drill it to the side, because if you drill straight down through at a 90 degrees and it needs to tilt and go vertical when this is at an angle, you're gonna have to make this hole bigger. So I think, yeah, so that's that information. I'm probably gonna I'll post this one and see how that goes, and we'll do another video after that, but I'm hoping that's at least some good information. You could use a piece of wood there instead of the metal, and for all that. So for now, that's this video.